Well, students, another day, another dollar. You know, that's what they say. But you don't get paid in dollars. You get paid in knowledge. It's even better. You can't eat it, but, well, you can't eat dollars anyway. Anyway, I'm on tangent. Let's get back now. So types of chemical bonds. All right, the moment has finally arrived. Atoms are actually going to form chemicals. Oh, yes. I can't wait. Let's see. Besides the noble gases, atoms all form compounds. So everything but the noble gases is going to form a compound. Atoms do this to receive a full valence shell and in the process form chemical bonds. Okay, so it's all about the full valence shell and they're forming bonds. There are three main ways that atoms bond together. Atoms will form either an ionic, so that's one, covalent, that's two, or a metallic, that's three, bond. The type of bond formed depends on the electronegativities, oh man, we're never going to get rid of that, of the atoms and the resulting behavior of the electrons. So we're going to be focusing a lot on electrons here. The interaction of nuclei and electrons through the electromagnetic force, remember that has to do with positive and negative, holds atoms together. Okay? The strongest type of chemical bond is an ionic bond. Okay, so strong. And I'm thinking ions already because it has it in the name, and I know ions are like positive and negative, but I'll wait to write that until I read a little more. Since these bonds are so strong, ionic compounds tend to be very hard to melt and very brittle. Okay, so basically that means very high intermolecular forces to connect it to our phases. That's why they're usually solids. Ionic bonds are made from metals and nonmetals, okay? Because of the very large difference in electronegativities, so this is, metals would have a low electronegativity, and the nonmetals would have a high electronegativity, so it's a big difference. Nonmetals will take electrons from the metal, high electronegativity, makes sense, and form an anion, so negative charge, whereas the metals give up their electrons and form a cation, so positive charge. The cations and anions are oppositely charged and will attract each other very strongly. Ionic bonds form repeating structures of positive and negative, so repeating, so one then the other, I guess, of positive and negative ions called crystals. So that's a repeating pattern. Since their attractive forces are so strong, ionic compounds are almost always solids, which is kind of what was said up here, too. Moving on. Covalent bonds occur between nonmetals. So both nonmetals? Yeah, I guess. Which will both have relatively high electronegativities. So nonmetal is high electronegativity. Instead of being transferred, the electrons are shared, so that each atom has a full shell. Again, we're going for the full shell. The nuclei of each atom then attracts the electrons, and this attractive force keeps the atoms together. Okay, hold on. So we have a nucleus, and we're sharing an electron in the middle. Well, we know this nucleus is pulling on this electron. We know this one's pulling on this electron. So the electron's not going to go anywhere, and they're both kind of like, it's like fighting over it, so the nuclei are together too, I guess. I don't know. Okay, where was I? Keeps the atoms together. These combinations of atoms are called molecules. Although the atoms are bound together, the molecules themselves typically aren't bound very tightly. Okay, hold on. The atoms, so the parts of the molecule are bound together. But the molecule, so the group, so molecule was the group of atoms, are not bound tightly, which means that covalent compounds are usually easy to melt. So easy, in fact, that many are liquids and gases at room temperature. So liquids and gases means low intermolecular force from our phases reading. What does this say? Okay, so this is covalent. It's got a molecule. And here we're sharing electrons, and then ionic, we're transferring. So I guess this would be the nonmetal, and this would be the metal, because it gives its electron. Now it's positive, aka cation, And this one would be the anion. This is ionic. Okay, alright, moving on. If all the atoms involved in a compound are metallic, then they'll all have a low electronegativity. Yes. I guess that's the only option left, right? If you're just combining metal and nonmetal. No mention of semimetals, though. That's kind of interesting. The electrons are left to wander around. Oh, they're homeless. Homeless. So sad. Which become cations after the electrons leave. So the metals become cations. The resulting sea of electrons forms a field of negative charge, which attracts the cations and holds them in place. Okay, so we've just got a whole bunch of negatives, basically, from the electrons wandering around. And so then if I shove a positive in here, it just like sticks to it. It's like Velcro, I guess, or something. It's just attracted to the entire field. I guess that kind of makes sense. And then we could stick multiple ones on here, and they're all attracted to this like field of electrons, field of negativity. Metallic bonds are almost always stronger than covalent bonds, but are usually weaker than ionic bonds. So it'd be like covalent is weaker than metallic, which is weaker than ionic. Okay, although usually solids at room temperature, metals will melt faster than ionic compounds. Okay, so this is like the intermolecular force here, and also the melting point, so it's kind of related to each other. Since the metal cations are attracted to the negative field of electrons, shifting the structure does not break the bond, and metals have a very malleable structure. I remember this means bendable. Okay, and here's basically kind of what I drew up here, actually. It looks like it's the same thing. Alright, last one here. Metals also conduct electricity well. We knew that already, didn't we? In order to conduct electricity, charges need to be able to move around. That, I don't know if I knew. So, conduct electricity means charge moves. So, positives, negatives, they have to move around. In a metal, the electrons are free to move. Okay, so yeah, right, because metals have the low electronegativity. Covalent compounds virtually never conduct electricity because the electrons are shared between the nuclei of the atoms and cannot leave. In ionic compounds, electricity is conducted only when the crystal's broken by dissolving or melting. So ionic conducts, but only when dissolved or melted. Breaking apart the ions, which are charged, allows them to move around and conduct electricity. Interesting. Okay. So we'll be ready to categorize and to understand the properties of these three types of bonds, and I'll see you in class.